We've already talked about some aspects of how results are delivered, such as directional information, for instance. In these last few slides, before looking at some case studies, I want to provide a little more detail about how InSAR results are typically delivered. I'll try as hard as I can to remain commercially agnostic. I'm not here to promote 3V geomatics, but understand please that 3VG's results are the only ones I have access to. This is an example of a snapshot style report designed to show the most recent displacement. A site might receive 2 of these every 11 days, one ascending and one descending. They are often designed to show displacement over a recent period and also include accelerating areas shown here in yellow. They are delivered rapidly, often within a few hours or 24 hours maximum perhaps, after receipt of a new image. In this automated example, when the data is good, very low displacement can be detected on the order of millimeters. And when there is more noise, then it's automatically more conservative. Other rapid reports might involve someone manually interpreting or analyzing data in which the displacement is annotated on a map. Longer term analyses provide the opportunity for a deep dive on a data set. And these analyze the data typically from both ascending and descending SAR images, combining the 2 sets of results into a single set of products. Results might cover the previous 3 months or longer. They might even go back as much as 20 years or more if the data is available. More data usually translates to higher precisions, and the directional information is usually provided too. This particular view is from Google Earth. Coverage is very good here. The pink mask shows areas that are too incoherent for the period processed. The small areas of white mask are either in shadow or layover or heavily foreshortened. The results can be packaged in a number of ways, and Google Earth is a nice, easy way of showing results for users that need something fairly basic. It can render results in 3D, which works great when the elevation model is reasonably accurate. Google Earth is very accessible, but functionality is limited, and it's easy to overwhelm it with too much data. A mine site might typically have 5 to 10 million measurable points, each with their own time series. These kinds of data sets are easier handled using GIS. This view is from ArcGIS. A geospatial database can be built that incorporates all the results for a site into some given period. Arc allows us to build functionality shown by toolbars, for drawing graphs, for instance, or for showing statistics. This example, for instance, shows graphs plotted in velocity space. So instead of displacement being graphed as cumulative, this shows how the velocity changes over time. So any downward trend is an acceleration and an upward trend is a deceleration. Web platforms for InSAR are also becoming very popular. All that's needed generally is a device with a browser and an internet connection. All the number crunching is done on the server side, so it can be very light, and the functionality for some is closer to GIS software than Google Earth. There's also no data management burden, no downloading and storing of large files, no worrying about software versions or software licenses. The data just sits on the cloud waiting to be used and is appended to every time a new analysis is conducted. Integration platforms are also a common way to access results. This one is Canary and provides a means to access and analyze all kinds of geotechnical monitoring datasets together, such as prisms, extensometers, ground radar, and of course satellite InSAR. That's the end of the lectures discussing InSAR theory. The next few lectures present some InSAR case studies.